Good day, Masinlok Sambales.
Good day to our beloved learners from grade 8.
This is your all art teachers, Teacher Brian Estigoy,
Teacher Luz Fontillas.
always at the service for Filipino learners. Yours truly is from BAMBAN National High School.
We will facilitate you in maximizing your participation as you learn today's lesson.
Welcome to Science 8 class.
Factors that affect potential and kinetic energy.
We will guide you in the first quarter on the third lesson this week.
Are you all ready, students, to embark on the journey toward learning science via radio?
Wow, that's great! This morning, make sure that you are all on your comfortable seats and properly listening to our broadcast.
At this moment, please get your self-learning module prepared by the development team of the module headed by Miss Cherry Madeline P. Samaco from Departments of Education, Caraga Region.
Distributed by your respective school for our topic today. You can also get your notebook and ballpen to take down notes about the lesson that we were going to discuss.
The word energy is used very often in our daily life. In science, there are many forms of energy. However, today we shall only focus on potential and kinetic energy.
In this lesson, it will help you master potential and kinetic energy. The scope permits it to be used in many different learning situations.
At the end of the lesson, you are expected to identify and explain the factors that affect potential and kinetic energy.
An object requires energy to do work. Consider two objects A and B that are about to interact with each other. When object A is pushed, an applied force is doing work on it. Object A possesses kinetic energy while moving towards a stationary object B. In this situation, object A loses energy while object B gains energy. When this happens, energy is transferred from object A to object B. This indicates that any object that has energy can do work.
Energy is the ability or capacity to do work. Its unit is the same as the unit of work expressed in joule in the International System of Units. 1 joule is the energy needed to accomplish 1 joule of work. A larger unit of energy, called kilojoule, is sometimes used. 1 kilojoule is equal to 1,000 joule.
Now, I want you to look at your copy on page 7 of your self-learning module. Look at the figure shown, a man lifting the box. You can see the man, the table, and the box. May I ask you, my dear students, which or who is doing work?
Is it the table,
The box?
or the man?
Yes, you are correct.
The man is doing work on the box.
Specifically, the force he applied while lifting is doing work on the box.
What is the direction of the force exerted by the man on the box?
What is the direction of the motion of the box?
Both are directed upward. Work, as said before, is a way to transmit energy. Therefore, when the man exerted force in lifting the box, he loses energy. Work is done on the box gains energy.
The work performed in lifting an object is equals to the potential energy the object gains. An object absorbs energy when lifted from the ground, and when he allowed to fall, it loses energy. The energy that the body gains or loses with respect to its position is called potential energy.
Yes, potential energy, and it is given by potential energy is equal to mgh, where PE is the potential energy in joules, m is the object's mass in kilograms, g is the acceleration due to gravity, which is 9.8 meter per second squared, and h is the height of the object from the reference point in meters.
Now, let us investigate that increasing or reducing the mass or height affects the potential energy of the object.
Situation A. Two objects of different mass are situated at the same height. A 10 kilogram box and a 20 kilogram box at the same height of 5 meters. The potential energy of a 20 kilogram box is twice as much as the potential energy of a 10 kilogram box when both boxes are the same height from the ground.
Why is this so?
The 20 kilogram box has twice as much the mass of the 10 kilogram box. Since they are of the same height from the ground, using the formula of potential energy, the potential energy is doubled.
Did you get it, class?
Yes, sir. Yes, sir.
That's great.
Let's take another situation.
Two objects of the same 10 kilogram mass are situated at the different height of 5 meter and 10 meter respectively.
The potential energy of the box that is 10 meter from the ground is twice as much the potential energy of the box that is 5 meter from the ground when both boxes are of the same mass.
Why is this so?
The box that is 10 meter from the ground has twice as much as height of the box. Since mass is the same for both boxes, using the formula of potential energy,
The potential energy is doubled.
Now, let's proceed on the other type of energy, which is the kinetic energy.
What is common in the following situations?
A running athlete on the track,
A flowing water on the ground,
a falling coconut from its tree,
a rolling rock on the seashore,
a soaring airplane into the air,
They are all moving and are acted upon by forces.
Any object that moves possesses energy and can do work.
An object that moves quicker can do more work than an identical object that moves slowly.
How much energy does a moving object possesses?
We say that the kinetic energy of an object moving at a certain speed is equal to the work done to make it acquire that speed.
What is kinetic energy?
The energy of a moving object, or it is also called energy of motion.
The word kinetic comes from the Greek word kinetikos, which means moving.
It measures the amount of work the object can do because of its motion.
This can be computed using the formula
Ke is equal to 1/2 mv squared, where Ke is the kinetic energy in joule, m is the object's mass in kilogram, and v is the object's speed or velocity in meter per second.
Let's take the first situation.
Two vehicles of different mass, 10,000 kilogram and 5,000 kilogram, moving at the same speed of 10 meter per second.
The kinetic energy of a 10,000 kilogram vehicle is twice as much as the kinetic energy of a 5,000 kilogram vehicle when both are traveling at the same speed.
Why is this so?
The 10,000 kilogram vehicle has twice as much as the mass of the 5,000 kilogram car.
Since they are traveling at the same speed using the formula of kinetic energy, the kinetic energy is doubled.
To fully understand the kinetic energy, let's have another situation.
Two vehicles of the same mass of 1,500 kilogram moving at different speed of 10 meter per second and 5 meter per second.
The kinetic energy of a car traveling at 10 meter per second is 4 times the kinetic energy of a car traveling at 5 meter per second.
Why is this so?
Car traveling at 10 meter per second has twice as much the speed of the other car. Since the mass is the same for both vehicles, using the formula of kinetic energy is increased 4 times.
Energy in motion is kinetic, like a boulder rolling down a mountain. Energy that's waiting is potential, like if that boulder's chilling as it get rolled. Law of conservation of energy can create or destroy, only changing. So objects moving, it's kinetic energy. You can transfer one object to another, and objects dance to the energy's potential, like a car static on a hill. It's staying still. It's so kinetic to calculate it. It's 1/2 times the mass times velocity squared. There are many types of energy in motion: light motion, radiant, thermal, and sound. Now here's an example: a car and bicycle are traveling at the exact same speed. Now which has exceeded kinetic energy? The car, because it has the most mass. Objects moving, it's kinetic energy. You can transfer one object to another, and objects dance to the energy's potential like a goal. Static on a hill, it's staying still. Onto potential, gravitational energy from our Earth's gravity type. You calculate it with the equation, mass times standard gravity times height. Now here's an example. What is the potential of a 4 kg rock on a 10-meter cliff? 4 times 9.8 times 10 equals 392 joules. Objects moving, it's kinetic energy. You can transfer one object to another, and objects dance to the energy's potential like a goal. Static on a hill, it's staying still.
Alright, you can practice your skills more in identifying situations that possesses potential or kinetic energy and on how to solve problems involving potential and kinetic energy by doing your self-learning module. I hope you learned from this discussion.
Law of conservation of energy can create or destroy.
Let me discover whether you have attained the learning competencies from your learning module on potential and kinetic energy through the outputs and the summative tests you will be submitting.
Static on a hill, it's staying still. It's so kinetic to calculate it.
Bear in mind that there are better things than getting high scores. What is important is you learn from your mistakes and become a better learner at the end.
Now here's an example. A car and bicycle are traveling at the exact same speed. Now it's
To our dear parents, help us guiding your children. It can make a difference on how well your child can accomplish the learning tasks. Kindly provide assistance. Thank you.
objects dance to the energy's potential like a goal. Static on a hill, it's staying.
If you have questions, just message your science teachers. I am sure they could help you.
I believe you can do it, learners. God bless in answering your learning modules.
Mass times standard gravity times height. Now here's an example. What is the potential?
Once again, this is your radio teachers, Teacher Luz Fontillas
And Teacher Brian Estigoy
of BAMBAN National High School.
92 joules. Objects moving, it's kinetic energy.
Goodbye, everyone.
And have a good day.
Objects dance to the energy's potential like a goal. Static on a hill, it's staying still. Energy in motion is kinetic, like a boulder rolling down a mountain. Energy that's waiting is potential, like if that boulder's chilling as it get rolled. Law of conservation of energy can create or destroy, only changing. So objects moving, it's kinetic energy. You can transfer one object to another, and objects dance to the energy's potential like a goal. Static on a hill, it's staying still. It's so kinetic to calculate it. It's 1/2 times the mass times velocity squared. There are many types of energy in motion, light motion, radiant, thermal, and sound. Now here's an example. A car and bicycle are traveling at the exact same speed. Now it says exceeding kinetic energy, the car because it has the most mass. Objects moving, it's kinetic energy. You can transfer one object to another.